Trey, is it Lyles? Trey Lyles, I guess, said, if you had the ability to decide, would you make Pluto a planet again? I would not make Pluto a planet again, because Pluto doesn't deserve to be a planet. The reason Pluto doesn't deserve to be a planet is because we now know, for the longest time, Pluto was... Look, you classify things according to the way you classify them, right? When you have something... when you have a class of things, you put them in that class. If it turns out that there are enough distinctions within that class to separate things in one class into two different classes routinely, predictably, and constantly, then it's time for a new class. So when the solar system consisted of a sun and planets, then Pluto was a planet, obviously. It was the 9th planet. But when you start to discover objects that are smaller than real planets, and when you discover enough of them, and when you discover, especially when you discover at least one, but now there are many more than one, that are not different than Pluto in any way, then Pluto's not a planet anymore. It is a planetoid. It's a microplanet. It is part of a class of objects that inhabit the outer solar system, was discovered first. It is, I think, just barely the biggest. There's another one that is within 100 miles of the size of Pluto, much further out. We found at least 4 or 5 of these, of at least very close to Pluto's size, ranging in size from Pluto down to Ceres. Ceres is also a planetoid. Why would we call Ceres a planetoid and not, let's say, Eros, an asteroid? Well, there's a couple of classification distinctions that astronomers use to decide the difference between a planet, a planetoid, and an asteroid. An asteroid, generally speaking, is irregular. The reason Ceres is considered a planetoid and not an asteroid is because Ceres is spherical, and that's a good sign. It's not in orbit around another planet. That would make it a moon, by definition, because all 4 of the Jovian satellites are much larger than Ceres. So if Ganymede, for example, were in orbit around the sun, or the moon for that matter, they'd be planetoids. They'd be small planets. They're spherical. That's important because once you reach a certain size, then the gravity of the object pulls it into a sphere. That's kind of sort of a cheesy way to put it, but that's not too far off the truth. You could have something the size of Eros, which is the gravity on Eros is so small that the gravity's not really much of a factor in the formation of the object. But when you get into something the size of Ceres, it's got enough gravity to make it into a sphere. So spherical is important. Pluto fits in the category of planetoid. It doesn't likely have a very differentiated crust, although we suspect that Ceres does, and we suspect Pluto does. Pluto, as George Freeland points out, has not only one satellite of its own. Pluto is, in fact, like the Earth, a double planet. There's only 2 double planets in the solar system. And a good rule of thumb is that a double planet is a planet where the moon is of significant size compared to the primary. Our moon's about a quarter the size of the Earth. Pluto's moon Charon is bigger in relation to to Pluto than the moon is relative to the Earth. Pluto Charon is probably the best example of a double planet in our solar system. Charon's probably 2/3 of Pluto's size. It's a double planet. And since then, we've found at least 4 or 5 other moons in orbit around Pluto Charon in the same orbital plane. So Pluto's its own little solar system. And it's not a demotion to call Pluto what it is. It's a planetoid. It's not, it just was discovered. And there's some evidence that the discovery of Pluto was accidental. The reason that, we had, let's back up a little bit. The ancients knew of 5 planets. Mercury, Venus, Earth, obviously, Mars, Jupiter, and Saturn. So we're not going to count the Earth. So they knew about Mercury, Venus, Mars, Jupiter, and Saturn because those 5 planets are visible to the naked eye, and they could be detected by farmers and shepherds. For as long as there have been people, they could see these little lights moving across the sky. The word planet means wanderers, by the way. Planets wandered around the background stars. The background stars were fixed, but the planets moved, and that was a mystery. So we didn't know about the planet Uranus until, I want to say 1760, something like that. William Herschel discovered it. Neptune came later, and Pluto came in 1930. But here's what's interesting. Uranus was detected because they noticed that the orbit of Saturn was not behaving quite correctly. There were once you could make very, very precise observations, astronomers realized that during parts of its orbit, Saturn was speeding up just a little bit, and then after a while, Saturn would slow down a little bit. Not by much, but by a noticeable amount. And the only way to explain that would be that there was a planet outside of Saturn's orbit that was pulling on it, and as Saturn came in on the inside lap, the planet would pull it towards it and speed Saturn up a little bit, and then as it passed it and then went around on the inside, then the gravity of that planet would be slowing Saturn down as it slowly pulled away. Very, very minor, but detectable. So once you notice this with Saturn's orbit, you can predict about where this thing should be, and because the planets more or less lie on a flat plane called the ecliptic, you had a pretty decent idea where this thing would be if it in fact existed. And brilliant astronomer named William Herschel did the calculations, figured out where this thing would be, put his decent-sized telescope, he had a pretty big telescope for a guy with his backyard, out there, took a look, and found the planet which he named George. Named it George. I don't know if he named it Georgius, but he named it George after King George. It was a planet named George for about 10 years or so, until finally the international community said, no, we don't think we like the idea of naming this planet George. So planet George was then given the name of the sky god Uranus. So, huzzah! Now, as it turns out, Uranus is, I think, 5th or 6th magnitude, which is just barely detectable to the naked eye on a dark night. If you had acute seeing at a good eyesight on a very dark night, and you knew exactly where to look, you could probably spot Uranus. However, it's so faint that it wasn't routinely, regularly observed, so it was not considered one of the planets known to the ancients. Now we have Uranus. Fantastic. Got its orbit plotted. Guess what? Uranus is speeding up in parts of its orbit and slowing down in others. That's an indication that there should be another planet out there. And they applied the same procedure. They find the planet Neptune, which is named after the god of the sea. So now we're doing great. Here's the part that's interesting. There were perturbations to the orbit of Neptune that indicated another planet, which would be the 9th planet, larger enough to cause these kind of perturbations in the orbit of Neptune. And so they went looking for this. And in 1930, an astronomer named Clyde Tombaugh, working at the observatory in Arizona, Percival Lowell's observatory, which he built to use to find canals on Mars, which were an optical illusion, didn't really exist. But working late at night in Percival Lowell's observatory, he used something called blink comparison. And what he did was, Clyde Tombaugh back in 1930 had taken a series of pictures of the sky. It's really brilliant if you think about it. Series of pictures of the sky, and he had a series of binocular lenses. And one picture would light up, and then he'd turn the light off on that one and turn the light on the other one, on these negatives, and he'd blink them. And so since the stars are in the same place, blink, 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 the stars are remaining absolutely still. The stars don't change at all. But anything that's moving goes doink, 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 doink. And that's what he did. Using blink comparison, he found that there was a speck, a very faint star. All of this is from memory. I want to say that Pluto's 12th, 13th, 14th magnitude, it may be even fainter than that, far, far, far too faint to see with the naked eye. But something was moving right where he thought it would be. He finds it. It's a microplanet. It's named Pluto. But one of the many reasons why Pluto doesn't deserve to be a planet is because Pluto's planet crosses the orbit of Neptune. For the time I was in high school, if you really wanted to be pedantic about it, you would say that the planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Pluto, and Neptune, because for about 30 years of Pluto's 200-plus year orbit, it's inside the orbit of Neptune, and that's suspicious and weird. Pluto might have been a captured moon that was ejected from the solar system, might have been a moon of Uranus that was ejected from its orbit, not ejected from the solar system, ejected from its orbit around its primary. I don't know how much this theory still holds water, but there was some evidence that Pluto was in fact a large moon of Uranus, that whatever caused Uranus to flip over on its side, some sort of gravitational interaction, was something that was going through the solar system, launched Pluto in its own orbit, which was very eccentric. The orbit of Pluto is very eccentric, which means a very oval compared to the mostly round orbit of the planets. It's not only eccentric so that it's inside the orbit of Neptune and then mostly outside, it's also inclined at a very high angle relative to the rest of the planets. So Pluto is not a planet. Not a planet. It's different than the other planets in many, many, many ways. It's too small to be a planet. Its orbit is not circular or close to circular like the other planets, and the orbital inclination is very, very high. It's way above and below the ecliptic. It's something that was captured or ejected, and it doesn't really belong as a planet. So anyway, that's the story of Pluto. A lot of people got all bent out of shape when they took Pluto out of the planetary world and put it into microplanet. I don't remember the name of any of these other microplanets. That's just poor publicity on their work. They need some marketing people. But as it turns out, there are other microplanets that are the size of Pluto, or very nearly the size of Pluto, and we've only discovered, there are hundreds of them, but we've only discovered 4, I want to say. Makemake? Sounds like one. That's about 2/3 the size of Pluto, and I forget the names of the others. But as we continue to look, we'll find more and more and more of them, and pretty soon we're going to find out that there are hundreds and hundreds of them the size of Pluto, and they're all a little bit further out there. They're all in distant orbit around the sun. They're all microplanets. They're all part of the Kuiper Belt, which is a collection of debris on the outside part of the solar system. Comets live in the Kuiper Belt. Every now and then, various gravitational perturbations will bring a comet in from the Kuiper Belt. Existing comets like Halley's Comet and the rest of them have already been diverted in and are now in eccentric orbits, but some of them are virgin comets, most of them, hundreds of thousands, probably hundreds of millions of them out there. Just frozen balls of ice the size of, Sherman Oaks. They're floating around out there, and then some fluky weird thing happens, slows it down just a little enough, and then thousands of years later it makes a close approach, spins off a beautiful tail because it's never been here before, it hasn't had all the volatiles cooked off, and there you go. That's how it works. We're basically a star with a sort of debris in close and then a large halo of more debris out further away. There's a smaller halo of debris between Mars and Jupiter, which we call the asteroid belt. It's a bit of a misnomer, really. Not really that much stuff out there, although there are thousands and thousands and thousands of them. It's just space is so big. So there you go. So no, I would not make Pluto a planet again. I think Pluto belongs being where it is, and no shame in being a microplanet if you're a microplanet.